Hello, welcome back to Omega Virtual Learning Platform. In today's presentation, I'll be talking to you about linear sequence. Please subscribe, share with your friends, and hit the notification button to be alerted of any videos that I post. I hope that by the end of this presentation, you'll be able to understand and know the features of linear sequence. You also know how to fill in missing terms of linear sequences, know how to generate the general formula or the nth term of linear sequences. You will also know how to list few terms of linear sequences when given the formulae. And lastly, you will know the application of linear sequences in real life. A sequence simply is a list of numbers in a particular order. When the term or numbers in a sequence, when the term increases or decreases by a given number each time, we call such sequence a linear sequence. Let's look at an example. Suppose I'll start a sequence with 1 and I keep adding 4 each time. I will get a sequence of 1, 5, 9, 13, and that carries on. We could then say that the sequence increases by 4 each time, and the term-to-term rule is adding 4 or positive 4. Another example, should I start a sequence with 8 and take away 3 each time? I will get a sequence made of 8, 5, 2, negative 1, and that also carries on. This sequence decreases by 3 each time, and the term-to-term rule is minus 3 or take away 3 each time. So from these two examples, we could see that linear sequences have constant differences between the terms. Constant differences, because from 1 to 5 is add 4, 5 to 9 add 4, and that repeats in this particular sequence. In the second example, from 8 to 5 we take away 3, 5 to 2 we take away 3. So that's also another constant differences. So linear sequence, they have constant differences between the terms. Now let's see, how do we fill in missing terms, especially when there is not just a missing gap but multiple gaps in a linear sequence. The first thing we need to do is to try to figure out the rule of the sequence, and once we figure out the rule, we'll be able to fill in the missing terms. So first, we do that by finding the difference between the first known term and the next known term. The difference means minus. So 19 minus 1 gives us 18. Second, we try to see the number of jumps we need to make from the first known term to the next known term. And we can see we have to make 3 jumps from 1 to 19. And the 3 jumps represent the 18. So to find out what one jump represents, we need to divide 18 by 3. And that gives us 6. And the 6 represents the rule of the sequence. So we fill it in by adding 6 each time. So for A, the missing numbers are 7, 13, and 25. Let's use the same process to find B. Difference between 18 and 3 is 5. Number of jumps from 3 to 18, 3 jumps. 15 divided by 3 is 5. So we keep on adding 5 each time. And our missing numbers are 8, 13, and 21. Let's look at C. Difference between 17 and 5 is 12. Number of jumps this time is 4 jumps. 12 divided by 4 gives us 3. So rule is add 3 each time. And our missing numbers are 8, 11, 14, and 20. Now D, we need to find the difference between negative 14 and negative 2. So you have negative 14 minus negative 2. And you need to remember from the negative number rules that negative followed by another negative becomes positive. So it becomes negative 14 add 2. That's why we have negative 12 as the difference between negative 14 and negative 2. Number of jumps, 3. Negative 12 divided by 3 is negative 4. So that means the rule is subtract 4 each time. So we subtract 4 each time. We're going to have the missing terms, negative 6, negative 10, negative 18. Lastly, difference between 2 and 23. You need to be careful. It's different between the 2 to 23. So the starting point is 2. 2 minus 23 is minus 21. Number of jumps, 3 jumps, divide. We have negative 7 as the rule. We take away 7 each time. And we find our missing terms to be 16, 9, and negative 5. So this is one way of figuring out the rule of the sequence and to use it to fill in the missing terms. Now let's look at the formula, the nth term. Nth term is just a formula that will allow us quickly work out any term in any given sequence. Generally, the formula will have a letter n in it, and the purpose of the letter n is to represent the position of each of the term in the sequence. We'll explain more as we go along. Now, I want you to understand something. In algebra, we make use of letters to simplify things. Saying 3 times table or multiples of 3, we represent multiples of 3 as 3n, and we represent multiples of 5 as 5n. As I said before, n represents the position of each of the terms in the sequence. So in the multiples of 3, the first multiple of 3 is 3, because 3 times 1 gives you 3. If you want the second number, n becomes 2. 3 times 2 is 6, and that is the second multiple of 3. So the n is there to help us know the position of each of the terms in the sequence and to help calculate missing terms as well. So times table, 5n is multiples of 5, 4n multiples of 4, negative 2n, negative 2 times table or multiples of negative 2. Now let's look at this. We want to list a sequence made of 1 less than the first 4 multiples of 3. 1 less than the first 4 multiples of 3. Let's begin with just the multiple of 3 first. So, the first 4 multiples of 3 are 3, 6, 9, and 12. And as we said earlier on, multiples of 3 in short could be written as 3n. So this sequence that you see in short is represented as 3n. We are now going to take away 1 from each of the terms. So taking 1 from each of the terms, we'll get a new sequence, 2, 5, 8, and 11. Now we know that the original sequence is 3n, and the second sequence has an aspect of 3n in it. You can see that this is simply 3n sequence but taking away 1. So we could easily write the formula as 3n minus 1. And 3n minus 1 becomes the nth term of the second sequence, 2, 5, 8, 11. So I'm now going to show you the steps in arriving at the formula for linear sequence. This is just a narrative for you to understand what this is all about. I'm now going to show you the steps in arriving at the nth term formula. I have 2 kinds of sequences: increasing sequences where the numbers keep increasing, and decreasing sequences when the terms also keep decreasing. Let's look at the first one, A. We first start by checking the rule of the sequence. So we know it's add 2 every time. Now the rule tells you the kind of multiples that is hidden in the sequence. So the fact that this is add 2 every time, that means this sequence follows multiples of 2. So we start by doing multiples of 2. So that's our multiples of 2, and multiples of 2 represented as 2n. Now you could see that we can compare each of the term with the original term. You can choose any point to compare, but I always prefer to choose the very first terms. So comparing 2 to 3, our aim is to get to the original one. This is a hidden sequence, so we want to get to the original one. You can see from 2 to 3, we have to add 1. So we can now confidently say the blue sequence is simply 2n plus 1. So our nth term for A is 2n plus 1. Let's look at the second one. We find the rule is plus 5, so which means the sequence has an aspect of multiples of 5 in it. So let's list multiples of 5. And multiples of 5 is simply 5n. We compare the first term. 5, we want to get to 2. 5 to 2, we need to take away 3. So therefore, the original sequence, the formula is 5n minus 3. Now let's look at the third one. That also plus 2. So it has an element of multiples of 2 in it. We list multiples of 2, which is 2n. We compare the first two terms. 2 to negative 5. If we are not sure, use number line to guide you. That is 2. You are counting all the way to negative 5. When you count, you realize that you are going down 7 steps, and going down is negative 7. So the formula now becomes 2n minus 7. We're going to use the same structure to work out the decreasing sequence. The difference here is that we have a negative rule. So we're going to list negative multiples. So negative multiples of 3 will give us negative 3, negative 6, negative 9, negative 12. And in short, it's represented as negative 3n. We compare negative 3 to 10. Again, if we're not sure, use number line. From negative 3 all the way to 10, you count, you realize that you are going up 13 steps. Therefore, the formula is negative 3n plus 13. Now, E, negative 4 multiples. We list them. Negative 4 to negative 3. You add 1. So the formula is negative 4n plus 1. And lastly, our rule is negative 5. So negative 5 multiples. Negative 5n. From negative 5 all the way to 6, you count. That means you go up 11 steps. That's positive 11. So the formula becomes negative 5n plus 11. So this is how we arrive or generate the nth term of linear sequence. Always find the rule. Use the rule to generate the hidden sequence. Then compare the very first term of the hidden sequence with the first term of the original sequence to know whether to add a number or take away a number to complete the sequence. We've now been given the formulae, and all we need to do is to work out the first 4 terms. Like I said, the n represent the position of each of the terms in the sequence. So if you want to find the first term, n represent 1. If you want to find the second term, n represent 2. If you want to find the fourth term, n represent 4, and so on. So this is purely substitution questions. If you know how to substitute values into expression, that's all you are supposed to be doing. So to find the first term, remember 4n simply means 4 times n. So the first term is 4 times 1 in bracket, then you take away 1, that will give you 3. That's my first term. Second term, 4 times 2 into bracket, then you minus 1, get 7. The third term will give you 11, and the fourth term will give you 15. Double check to see if you are right. From 3 to 7 is add 4, add 4, add 4. It confirms the times table, 4 times table. Number 5, B, 5 minus 2n. The same principle, substitution. 5 minus into bracket 2 times 1. That works out as 3. First term. Second term, 1. Third term, -1, -3. Double check to see if you are right. 3 to 1, you take away 2. 1 to -1, you take away 2. That confirms -2. So -2n. That's what it confirms here. Next one is -3 times 1 in bracket. Then you take away 4. That will give us -7 as the first one. Substitute 2, -10. Substitute 3, -13. Substitute 4, -16. On this side, we are supposed to work out the 50th term of each of these sequences. So we want to see what position 50, what number is going to be there. Position 50. So n automatically becomes 50. So you just substitute 5 n minus 3. Where n is 50, you substitute, and that will give us 247. For B, we still substitute 50 into the expression 15 minus 4n. That gives us -185. And C, -6n minus 8. Substitute 50. When you work it out, you should get -308. So this is how we use the formula to list the first few terms of a sequence. So the formula will help you work out any term in the sequence. Let's look at application or real life situation. We have a situation where Joanna makes patterns out of dots. Below are the first 4 patterns. So we have pattern 1, 2, 3, and 4. And the question is, suppose Joanna has 92 dots. What is the biggest pattern ever she could create? Now, this kind of question, the first thing is to change the dots into numbers. So we count the number of dots in each pattern. So we have 5, 8, 11, and 14. You need to take your time to count carefully, because some people, what they do is, oh, this is 5, it looks it's double 10. No, be very careful and take your time to count. Now from the sequence, try to find the formula, the nth term. You should by now know the steps in finding the formula. So it follows a 3 times table. So 3 times table, which is 3n. Compare 3 to 5, we need to add 2. So our formula for the sequence is 3n plus 2. Now, what we need to do is that we are saying that the nth term will present nth term equals 3n plus 2. Now, what we need is what n position will be the biggest pattern from 92 dots. That is, we are going to investigate, is it going to be the 40th term? That means, is it going to be in the 40th place? The 92 dots, when I make the pattern, is it going to be in the 70th place, in that order? This is what we are supposed to investigate. So the easy way is to equate your formula, 3n plus 2, with the number of dots. You equate them to form an equation, then you solve the equation. -2 from both sides. 3n equals 90. You divide 3 both sides, and you have n equals 30. So that means that if Joanna use all the 92 dots to create a pattern, it's going to be in the 30th place. The 30th place pattern will have 92 dots. That's what it's all about. So remember, questions like this, change the patterns into numbers. Work out your formula. Equate your formula with the number of dots or number of items that is given, and solve for n. Solve for n. So 92 dots will make the 30th pattern. Let us now look at, if we're given a sequence, how do we predict as to whether a particular number will be in the sequence or not in the sequence. So we have a sequence 1, 5, 9, 13. The obvious or the temptation here is that, well, there is 5 in the sequence, so it's likely that 95 ending in 5 could be possible that it's going to be in a sequence. But we need to be very careful here. You need to investigate that. So the first thing we need to do is to find out the formula. So our formula from the stuff that we've been using before will give us 4n minus 3. And remember, the n values are discrete numbers, like the first number, the second number, the fourth number, and so on. There's nothing like the 4.7th term or 4.8 term or 4.5 term. Has to be exactly discrete numbers, distinct. So if 195 is in the sequence, when we form an equation and work for n should give us an integer. It should give us a proper whole number. So to find out if 95 is in the sequence, equate the formula with 95. The reason is we want to work out the end position of the number 95. So we equate the formula with 95 and solve our equation. Add 3 to both sides. 4n equals 98. Divide 4 through both sides. We realize that n gives us a decimal, 24.5. And as I said before, n has to be a distinct, discrete number. So that means that 98 will not be in the 95 will not be in the sequence, because it's neither 24th term nor the 25th term. It's between 24th and 25th, and there's nothing like that. So we can confidently say that if we carry on adding 4, we will never get 95 in this particular sequence. Reason is n must be an integer, and this 24.5 is not an integer, not a whole number, so it is not in the sequence. Look at the second one. Is 73 in this sequence? Also, well, none of the sequence or the terms in the first 4 terms has a 3, so you can say it doesn't seem like. But hang on, let's investigate. Find the formula first. You should by now know the steps in finding the formula. Our formula is 3n minus 5. Let's find the n position of the number 73 by equating 73 with 3n minus 5. We now solve for n. Add 5 to both sides. Divide through by by 3, sorry. We realize that n equals 26. It's exactly the whole number that we have been looking for. So that means that if we carry on this sequence, in the 26th place, we're going to see the number 73 there. So we say yes, because 73 is the 26th term. That brings us to the end of lesson 1 on linear sequence. I hope you've enjoyed it. Please subscribe, share with your friends, and hit the notification button. Look forward to the second lesson, and I will be talking to you about quadratic sequence. Second lesson, quadratic sequence. Thank you very much for watching.